Hello everyone, welcome back to my channel Saisha. This is Amogh Kaliwal. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we understood the assumptions of distribution, definition of geometric distribution and its application on different examples. In today's video, we will understand the definition of binomial distribution, comparison of binomial distribution with geometric distribution and Bernoulli's distribution, and the application of binomial distribution on different examples. Let us understand the binomial distribution definition and formula utilized to understand binomial distribution. By definition, binomial distribution is a discrete probability distribution which has the number of successes in a sequence of independent experiments. Which means if you have 10 number of independent experiments in which you want to identify the probability of 6 successes, then binomial distribution would help us to understand that. Probability density function of a binomial distribution is NCR into P raised to R into Q raised to N minus R, where NCR means the combination of R trials in an experiments. P raised to R means P represents here probability of success, R represents the number of successes, Q represents the probability of failure, N minus R represents the number of failures. The expected value of a random experiment X is equal to N into P, where N represents the number of success, P represents the probability of success. Variance of the probability distribution for a random experiment X is equal to N into P into Q, that is the number of success, the probability of success and the probability of failure. Now let us understand the criteria for binomial distribution. Let us understand some of the criteria which are required for binomial distribution. The first criteria is the number of trials are fixed, which means consider you are tossing a coin for 10 attempts. Here 10 represents fixed number of trials, or out of 100 cars passing through the toll booth, how many are red? So here 100 is a fixed number of cars, that is fixed number of trials. Each observation or trial is independent of each other, which means the probability of success of previous trial is not dependent on the present trial. Similarly, the probability of success of a present trial is not dependent on the future trial. The probability of success are same from one trial to another, which means consider you toss a coin. Each time the probability of getting ahead is 50%. That says that the probability of success is same for all the trials. Now let us understand the process to conduct binomial distribution. The process to conduct a binomial distribution are 3 steps. In step number 1, you run a series of independent trials. In step number 2, the probability of success for each independent trial is same, and the outcome of each independent trial has an either success or a failure. Then there are finite number of trials. The independent trials which we have considered are finite, and we are interested in the number of successes or failures in that finite number of trials. You can observe there are some similar steps which we use to conduct geometric distribution too. Let us understand the difference parameters between the Bernoulli's distribution, geometric distribution and binomial distribution. Comparison of the distribution. In Bernoulli's distribution, we have one experiment which has only 2 outcomes, yes or no, failure or success, etc. In geometric distribution, we are estimating the number of failures before the first success. And in binomial distribution, we have fixed number of attempts, that is n attempts, and in those n attempts, we estimate the number of successes. This is how we can differentiate the three distributions. Now, let us understand the application of binomial distribution on different examples. Let us start with a coin toss example. We are tossing a coin 10 times and we are interested in calculating the probability for exactly 6 heads. In an ideal condition, the probability of getting a head is 0.5 for a coin toss. Then probability of getting a tail would be 1 minus 0.5, that is 0.5. As our number of trials are fixed to 10, here n would be 10. Similarly, we are exactly interested in 6 heads. Hence, R is 6. The probability density function for a binomial distribution is NCR into P raised to R into Q raised to n minus R. That is, combination of R trials in n attempts into probability of success raised to the number of successes into probability of failure raised to the number of failures. By substituting the required values in the equation, we get the probability density function for exactly 6 heads is 0.205, which means that we have 20.5% chances of getting 6 heads in a 10 attempts trial of coin toss. Now let us understand the second example. In the second example, we have a group of people who purchase pet insurance. From observation, we see that 80% of the people who purchase pet insurance are women. Now, we have chosen 9 people randomly from the group and we want to identify exactly 6 people are women from the chosen randomly selected people. To solve this problem, we have probability of success as 0.8, that is 80% of the people are women. Then probability of failure would be 0.2, that is 1 minus 0.8. We have randomly chosen 9 people from the group. That's the reason the n attempts are 9 and we want to identify exactly 6 people are women in the selected group. That is R is equal to 6. The probability density function of the binomial distribution is NCR into P raised to R into Q raised to n minus R. Substituting the above values into the equation, we observe the probability density function value as 0.176, which means 17.6% chances we have exactly 6 people from the randomly chosen set of 9 as women. Now let us understand the third example of binomial distribution. A person is in a bowling court and the probability of person knocking all the pins is 0.3. If he has 10 attempts, then we want to understand what is the probability that he will knock all the pins in less than 3 times. To solve this problem, we have P is equal to 0.3, that is, he has probability of knocking all the pins as 0.3. Then Q would be 1 minus 0.3, that is 0.7. There are totally 10 attempts, hence N is 10. We want to understand that the person will knock all the pins in less than 3 attempts. That is, R is less than 3, which is equal to R is equal to 0, 1 or 2. we have the probability density function for binomial distribution as NCR into P raised to R into Q raised to N minus R. Now, to understand the probability density function for less than 3 times in 10 attempts, we have to calculate the probability density function for x is equal to 0, x is equal to 1 and x is equal to 2 and take a summation of 8. By utilizing the values into the formula, we can calculate probability density function for x is equal to 0 as 0.028, 0.21 and 0.233 for 1 and 2. The summation would give us 0.38 as the probability density function for less than 3, which means that we have 38.2% chances that the person will knock all the pins in less than 3 times under 10 attempts. These are some of the examples of binomial distribution. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.